I think till Pradeep gets set up. Now, could you go back and say how the database and the once you feed the sampler to the machine, I think we can probably come back after Pradeep goes through the sampling one. Let's go through that step also one more time. Thank you. Pradeep, I think you are set, right? Sampling.
Yeah, can you see my screen?
Yep, very good, very well. Thank you.
Okay, this is the flow meter. You can see.
Yeah.
This is the flow meter. Using this flow meter, we can measure how much water we pump through the this equipment. Then we can calculate the. This is the machine. You can see clearly. This is the pump. Pump is located in this side, and that water coming from this side and pump through the net. This is the net. You can see here that micro planter net. Then water come out from here, and that flow meter is located here in this side.
Pradeep, are you using a cursor or something? No,
you cannot see a cursor, ne?
No, what we see is like the file folder.
Yeah.
File folder.
Yeah.
Did you open that image or what?
Yeah, I opened the image. Maybe
no,
I not share it.
We cannot see.
Okay, so sorry. Maybe I did some mistake. Wait. Which screen I shared? Wait. I think I wrong screen I shared. Wait. Why it is can't share? Give me 1 second.
Okay.
Can you see now?
Yes, can.
Okay. Yes.
Yeah. This is the machine, that albatross, and this is the pump. This part is located the pump, and water when we put inside the water coming from this side and go through this planter net. This is the net, that micron net. You can see we can collect our sample from this part. This is like a cone shape net. Cone shape net. Then that flow meter is located in this part. Then we can calculate how much water is pumped through this equipment within unit time. Okay, then I have a video. This is the bed, and we have some ropes we can put inside there is some weight. Then we can go to in the levels like 1 feet, 2 feet, or bottom of the water body or something like. And we can manage the height of the water level using these ropes. This is the very simple equipment actually. Then what are the things we pump with water is remaining here, that less than higher than the 300 microns. Then later we have to we can dismantle this part and get out our net. Then we have to wash out, and we collect our sample from this side. There are some separate nets for that. Okay, I will show that.
A couple of questions. I'm sorry, I'm learning this now. When you the time taken to remove it and get the sample out, how long it will take normally in your operations?
Yeah, actually in a river, to set up this machine and take the sample and wash, at least take I think Johan more than 30 minutes, right?
Yeah,
for one
around
sampling.
40 minutes.
40 minutes, around 40 minutes.
40 minutes we can get the sample.
And how many samplers we have in the country?
Now we have only 4 nets.
4 nets. And then this net, is that a proprietary thing? This 300 micron net?
Yeah.
Is that a proprietary thing, or can we make more? Can we make more samplers?
No, this is actually that 4 nets coming for this machine. I think it is standard size. I don't know exactly it is available in Sri Lanka or no.
All right. Okay.
But the thing we can do, Dr. Ananda, we can wash our sample from the field. That is one option, but
Right.
I don't know exactly it is good or no, but
Mhm.
we can do that, but it take time sometimes.
Can I intervene, Dr.
Yeah,
Pradeep?
yeah.
Dr. Anand, the machine already inbuilt with 4 plankton nets. But during the field, actually we can wash out our microplastic into another nets.
Net.
So that's how we preserve our microplastic samples, and we can send to somewhere, the laboratory or another foreign country.
The second net
And
you are talking
these,
about, it is again a normal net, or you have to get it again from, it is come with the machine.
no, the 4 nets that inbuilt, so those nets we have to get from that Pirica.
Machines.
But that the storing nets,
I store in it.
those
Okay,
3 nets we can purchase from local.
local.
That's available.
Because yeah, can you see in this new image?
Yes.
Yeah, because this not, I think this is that net is coming that its standard size, because it should be fixed to this part of the machine.
Right.
Yeah.
You know why the reason I'm asking this, Pradeep, is now if we can ask Pirica, say supposing we have one machine with 2-3 sets of nets, and then we take one out, and then while the other team is washing that into another container, we can fix the other net and dip the sampler now.
Yeah.
So we are having,
We can save time.
hand multiple nets. So we can, I mean, that is one thing we can ask Pirica to instead of one net per machine, we can use multiple nets per machine, right?
Yeah.
Dr.
Right.
Anand,
Yeah.
for the washing thing, it will not take time. Within 5 minutes, we can wash the net and take into the storing nets.
All right. Okay. Sounds good.
Yeah.
I think we can do this work by utilizing these equipment and the nets. So I think that those are enough for the work. But we need to purchase that storing nets. I know that's locally available, but we have to purchase that one.
Okay. All right. So now I think we got the level of details that we require to. I mean, this is operational details I'm asking because it is required to time it and also to cost it. Good.
Yeah.
Oh, this is wonderful. I think we got the understanding of this. And then, Johan, can we go back to the, thanks, Pradeep. Can we go back to this, the analysis part? Once you get the sample, what happens next?
Yeah, once we get the sample, so now we want to wash that one to remove that organic and inorganic particles attached to the microplastics. And then that microplastic particle we can keep on the ATR machine. So ATR machine, as I mentioned, that's the measurements are indicating because of the reflection of that IR. So then we can, the machine will give that spectrum to us, and then we can compare that spectrum with the database or the library in the machine. So those are the steps.
Right. So what is the result coming out? Is that grams of micrograms of microplastics in that sample, and what are the details coming
that's
in the
coming from actually that's coming from actually type of plastics. So they are given some scores.
Do we get the composition as well? Now,
yeah, according to the composition. Hello?
Yeah, please go ahead.
Yeah, according to the composition, the ATR machine will give some scores. Right? So according to that scores, we can guess that might be a HDP, that might be a polyethylene terephthalate, like that. We can guess.
Okay, and then we get the quantity also, the weight of that.
Yeah, normally we are giving that units as the number of particles per volume in water samples. So we need to
Okay.
calculate number of particles.
Okay, so number of particles bigger than 300 microns.
Yeah.
In that given whatever the meter cube we pumped.
Yeah, that's
right.
right.
So that's pretty much a load measurement, right?
Yeah, yeah.
And then it's broken down to different kind of plastics within that measurement.
Yeah, yeah, we can get.
All right, wonderful. So that means we can probably say how much of PET is inside that sample, and compare the compare PET from spatially as well as temporally, right?
Yeah, but the thing is, if we have lot of particles, right? So we need to analyze. We can analyze just particle by particle. Imagine we have more than 100 particles. So we need to keep more than 100 times the TR machine and do identifications.
Okay, that I think that's a hard one to understand. Okay, now in our when you feed the sample to the machine, you are pretty much feeding a particle.
One particle.
Yes. Yeah.
How do you isolate that A particle through a microscope?
Sorry?
How do you isolate that A particle? How do you sample it from the now you get from the filter, you get bunch of stuff, no?
Yes.
Then how do you isolate the one and pick the one going into the machine?
Maybe we can use microscopic analysis, so maybe we can see that particle. Most of the time we can see that particles.
Okay, then you through like a okay. So you through I mean using a forceps or something, you just pick it up.
Yeah, we can use forceps or something, and we can keep on the instrument.
Right. Okay. Let me ask. I'm so sorry. I'm asking these questions for to learn this. Now, now you said ADR, right? ADR stands for
ATR. Yeah.
ATR.
ATR stands for actually. Attenuated total reflection.
Total reflectance.
Reflection.
A is for attenuated?
Yes.
Okay. Now, how does that vary with the work that is happening in Avanti working in IFS?
Actually, I am also using the ATR FTIR instrument for microplastic identification. As Johan explained, I also did visually separated the microplastics, and then those particles were analyzed using ATR FTIR instrument. So then we can identify what are those microplastic based on the libraries and the previous publications as well.
Right. So I think then where is this word Fourier infrared spectroscopy came?
ATR is one of the mode which is in the FTIR instrument. There are two types of modes. One is in one type of mode, the IR radiation is going through the sample, but in the ATR method, it is reflect on the surface of the sample.
Okay, now, okay, thanks so much for this information, because now it makes sense. Okay, now let me push this into Sena, if you permit me, while we are on the thread, let me push this one more level. Now we have say mixed isolated sample of microplastics from the net. Now we know the total weight, and then we picked one other particles from there and put in there, and then we identified the type of plastic using ATR. Now, how do we relate to the ratio? Like say we got a bunch of microplastics, so then probably if you take 10 random samples from that mix,
Yeah.
or 20 or 50 or whatever, then we can say out of the 50 randomly there were PETs of say this percentage, and HPP of this, HTP of this, and all that. So in that event it will be a random sampling of the sample out of many samples.
Yeah. Yes.
Could you shed some light, like how do you proceed like that, so that we can get an understanding of the statistical analysis or statistical evaluation of type of plastics and their representative structure?
Actually, generally we are doing the visually observed what are the most common microplastic in the sample, and then isolate those things from the sample and identify using FTIR instrument. If we need to quantify those things exactly, we have several other instruments as well, but I don't think we have those facilities in Sri Lanka. For instance, pyrolysis gas chromatography we can use to quantify the different type of microplastic in the whole sample. So I think that is the best way for the quantification. The ATR instrument in the FTIR is not giving very much good information about the quantity of the different type of microplastic in that sample. We can just, we cannot exactly quantify those in the sample.
I think, Avanti, this is very good information, because this really help us to formulate this sampling strategy and analytical protocol. Now, can we talk a little bit about this gas chromatograph business? Now, that means like you are pyrolyzing the sample and then injecting into a column, right?
Yes.
And then you get do you need standards to know the time, the peak, the time of the peak, and the things like that, right?
Yeah, I am not much familiar with this instrument, but I have some data of this instrument in my ongoing paper.
Right.
Because some of the technicians did this in Korea when I was working in Korea as a postdoctor. So,
okay.
So I am not much familiar with the instrument, but in that instrument, the principle is, yeah.
Okay, basically, can we, so you, please go ahead and finish what you started saying.
Yeah, the principle is first the microplastic sample is pyrolyzed to the gas. Then this gas is inserting into the gas chromatography and find out the different components. Based on that, find out the different type of microplastic in that sample.
Okay, have you ever run into any papers that couples this mass spectroscopy and GC on this one?
You mean whether I have published?
No. Has seen?
Yeah. I can share.
No, I mean, have you seen? Because normally in the metal analysis, probably Johan, you can help me. Now you guys combine the atomic absorption or ion chromatography with mass spectroscopy, no?
Yeah.
Yes.
Right now, can we think something in this line into this one? I'm just throwing a challenge, actually.
You mean whether the metal analyzing instrument can be used to analyze microplastics?
No. Basically, now the principle, what they do is like you have a mixed set of metals. So you just throw into that one, so that will separate and analyze. And then you send it through this ICP, inductive coupled plasma and mass. Then it will give the composition and the type of the metal. But I think now we are in a very similar situation. We have a different composition of plastic and need to identify how much of that sample has what kind of plastic, right?
Yes.
So I'm just pushing the existing boundary to get to a different level so that we can, I mean, when you do sampling, say if you are in Modera, then we should be able to say like, okay, this much of plastics came out of that. This is the composition. Is that right? I mean, saying if you can get to that level, we have a lot of information in one go, right? But what I like to see is like, once we do all the hard part, I think Pradeep showed us, we go and get the sample and all that. But with the same sample, if you can generate additional information, if you can, I'm sure the method should be somewhere.
And
all right, well, let's work on it. I mean, today's the first round of discussion. So I think I'm just putting these ideas in our head so that we all can go back and the work done by University of Minnesota on PET. Now, I have seen these separation techniques they use to certain things in their videos. Anyway, I think I think we can, as a team, we can look for a little bit literature.
yeah.
And then also see whether this, through this project, we can push the limit a little bit so that we can enhance the Sri Lankan capacity. So over to you, Sena.
Yeah, I think it's quite clear. The same question I had, Anand, the two questions were, number one, if we get a sample, unless we can tell what percentage of material is there, say so much of PE, so much of PP, the collection of microplastics and doing all these exercises is not, I think, sufficient. The analysis should tell us some decision making to be done. We know so much of this percentage of microplastics is coming in the river. This is the, I think, ultimate decision we have to make. Otherwise, I mean, just trapping the microplastic and saying we are having this will not be sufficient. So we have to find a way to give these percentages. So I think in addition to that, we didn't hear from Avanti. I think, so you answer these questions. Can you please tell what you can do with the IFS as well as with the university?
Yeah, in IFS, I am working as a honorable visiting scientist. So therefore, I have access to the FTIR instrument there. However, for these samples, we may need to pay for the samples. As I understood, they are taking for one sample, it is around 1,500 per sample cost. So since I am working there, I can, I mean, I do not need to wait in the queue to analyze my samples. That's kind of benefit is there for me. And one of my MPhil student is also working there, therefore I can get help from him as well. And in the faculty side, we don't have instrument for this type of analysis actually. So therefore I have to take the advantage from IFS, take the benefits from IFS to analyze these microplastic samples.
One question from all three of you. Don't we have FTIR in any of the universities in the country?
No, I think we have in Peradeniya also, but not in our faculty.
We also have, but it is not in our control.
But we'll be able to get their assistance, I think, if necessary. No?
Yeah, no problem. We can get that way, but the thing is, we need expert to analysis for this analysis purpose. That's the problem.
But you mean the
Yeah,
instruments
the
is there,
thing-
but the person are not there, or person are there?
Because the ATR mode is little bit tricky. We need to have a little bit more experience to use the ATR mode,
Oh,
not like the transmission mode.
But if a person is trained on the FTIR, they should have that the capacity to do it, the training.
Yeah, must be. But some instruments, they do not have the ATR facility as well,
Okay.
because it has to buy separately to the instrument.
So,
There is-
Dr. Pradeep, can you check from the university? I believe it may be in the science department, science faculty. So, whether this is available, the ATR mode is available, and whether people are available. So, because I think then we know all the resources in the country.
Yeah. The Jawadanapura has that FTI machine, but I don't know this ATR. I will check and I'll let you know.
Yeah, because we want to pool all the resources in the country as much as possible.
Okay, I will check, sir. Okay.
Sena, can I ask the question like, actually probably Avanti can answer, how long one sample take?
It's around 20 to 40 minutes. It's
So
depend
that's
on the quality of the spectra. Sometimes we need to do several scanning to get a good spectra. Therefore, it takes time around 40 minutes.
So basically, we are talking about like 5 to 10 samples a day.
Yes.
Right? Sena, that's we need to take note of that.
Yes.
So we could continue to sample, but the analytical part might be the part that we need to either find places to expand, or I think okay, let's keep that also as one of the important factors.
It's a constraint,
Okay.
I think another important thing is, as you mentioned, we have to think about it and talk about it more in detail. Nihal was talking to me last night. I don't know whether Nihal is there, I think.
Nihal is there.
Because he was talking about the sampling points and the sampling, the times, all that. So I think that's something important. Another was, I think, highlighting. That's something very important for us.
And the criteria.
Yeah, and the criteria. Yes, that's right.
I think let's early, probably sometime next week.
Yeah.
We should be having that discussion, the designing part. I think with today's information, probably I think we need a little bit more time to digest. So Sena, if you permit me, I have another question to ask our colleagues.
Please go ahead. Yeah.
Now, we talked about these pollutants that are absorbed onto microplastics. Now, this again, I'm just asking this question to learn. I heard now, if I were to find a location in a river and then have a long-term experiment to say that the microplastic absorbed pollution is now getting worse or getting enhanced. I see people tracking phthalates, and I see again people tracking POPs, this persistent organic pollutants. Now in this context, I'm not very convinced that what we should be doing in these kind of situations in Sri Lanka. What are your opinion? Now, focusing on the pollutants that are linked to microplastics that eventually will provide the threat to the fish or the food chain. I think that thinking, because to tell the story, we need to get to that level at some point. So just like to hear a little bit from our colleagues on this angle.
Yeah, Dr. Anand, what you said, That is my ongoing faculty research grant.
Okay.
So that's what we are doing now. So we are collecting microplastics and we are identifying the chemicals that are attached to the microplastics, basically that POPs, heavy metals. So, and we are targeting some antibiotics as well. So those chemicals actually we have to identify through the GCMS analysis. And the same time, I thought that to get samples from water samples to extract those chemicals from the water as well. So then we can compare the concentrations of water as well as the plastics.
Okay, so it is happening in Sri Lanka and it can be done, right?
Yeah, that can be done, but most of the laboratory facilities they have several they can identify several chemical compounds, but basically they equipped with to identify some pesticides. So we normally call that POPs, but POPs means there are several chemicals, no?
Right. But at least it will get
all
us
the
somewhere.
chemicals we cannot analyze in Sri Lanka. That's
Okay.
the thing.
Now, then tell me this. Now, in our earlier ATR mechanism, we were trying to pick up the A particle and then trying to analyze that. But now, if you want to tell the policymakers something about pollution, rather than trying to do this ATR thing, you polarize the whole sample and then run through this GCA, I mean, all this technique that you come up with the total amount of POPs irrespective to the type or variety of pesticide or type of metal, whatever. Then we have a measurement, Sena, please start thinking now. Now we have a measurement, the amount of POPs that a kilogram of one weight of microplastics carry. Is that make sense, Johan?
Yeah. We can
right.
get that.
Now, will that be a more convincing argument for policymakers rather than trying to say like this much of PET and this much of PP?
Yeah, according to the literature, there is no much concentrations attached to microplastics, but we can guess and we can say that this much of POPs and antibiotics and some heavy metals attached to that microplastics. Since that microplastics normally we know that it's bioaccumulation inside the bodies, so then it will again toxic to that species. So that's what we can say actually.
Now, I think we are on a very good track here, say, and probably now, because for the extended producer responsibility, if you can say, okay, this much of PET went, so the PET manufacturer should take care of this.
Yes.
But here we are on the health side. And also ocean plastic, the main complaint is the accumulation in the food chain.
Yes.
So now I think let's start thinking this little bit more. And Avanti, are you involved in this kind of work?
Actually, I did not in Peradeniya. When I was working in Korea, I did analysis with microplastic in soil, how they transferred trace metals to the plants as well as through the soil profile. And we found that when microplastics in the soil, the transferring of metals to the plants is increased as well as through the soil profile.
So it is like a catalyst?
It is like a carrier of trace metals. Because on the surface of microplastics, there are several types of functional groups. These functional groups can adsorb trace metals in the soil, and then those plastic particles can move through the soil profile as well as those can adsorb by the plants.
Oh, I see. So that means like those hydrogen bonds or low Arrhenius energy, so they come closer to the plant and all of a sudden that jumps.
Yes, yes. And those microplastic also can be absorbed by the plants. Small particles can be absorbed.
Okay. Now, these are the stories, Sena, we need.
Yeah.
These are very, I mean, I like this discussion because I think we are learning many angles.
Dr. Avanti, that microplastic come to the edible part as well, right?
Yes, of course.
That is the dangerous thing.
Now, Avanti, now the angle we mentioned about that taking a water sample and then get the microplastics and then analyzing this pollution aspect, breakdown or a general total of something. What do you think about it?
Sorry, I missed the conversation.
No, basically now you were following a thread from Johan, instead of like trying to spend a lot of time trying to do the ATA, while doing ATA, we also do persistent, total pollutants in given weight of plastic or microplastic. So that we know that these plastics also not only the plastics are not only there, but they do also are already associated with certain pollutants that are harmful in the long term.
Yes, that's true. So therefore, they are acting as a carriers in soil as well as in water.
Right.
So, yes.
So both these can be done, I think, with the plastic samples, microplastic samples we collect from a river.
Yes, we can analyze what are the other pollutants associated with those microplastics.
That's where the beauty comes in. Otherwise, getting a sample will not get us too far.
True. Yes.
All right, great. Now, how do you, Sena, back to you. I think I've just asked too many questions for the day.
Yeah, I think we have one question. I think Anand would like also to know how can we work with you? I mean, what is the mode actually? Are we working with the universities? So Anand will, I think, require this information.
Well, I do have the methodology configured already, Sena.
Yeah.
What we do is the universities allow the staff to accept money, but they have to, there are certain staff, they accept money and not declare, but there are a lot of staff who accept money and declare and pay that 10% to the university. Is that the work, Avanti, you guys work? It's famous in Peradeniya. You do that with Peradeniya University all the time.
Yeah, because I am still not aware about this process, Dr.
Okay.
Anand.
Right. Basically, I think we can do it, Sena, because we either bring the university staff as consultants, and it is them to safeguard themselves from the university management.
Yeah.
The mechanism university management has proposed is like, okay, give us piece of it. So I think that part fairly clear, Sena.
If all three are comfortable with that, I think we have no problem. No, then.
Yeah. That's totally fine.
So, Johan, one more question now in this persistent pollutant analysis. Now, I think Avanti gave us a ballpark picture around 1,500 rupees per sample for the analysis. Likewise, now can we just get I think you can give a little bit higher, because we wanted to see like how many samples that we need to do and all that.
Yeah, that's how many samples mean. That's depending on the sample locations, no. So,
yeah, but no, per sample, how much it will cost to run through the GCMS?
Yeah, actually, the POPs, antibiotics, and heavy metals analysis. The heavy metal analysis we can do here, but I don't know POPs and other chemical compounds attached to the microplastics. So in my project, that part will do by Dr. Amile.
Okay.
So
could you just for us to put in the budget? Could you get a number? Like if you do only heavy metals, how much it will cost, and if you do the whole thing, but amila might be having some cost also, right? So is he having enough resources on his end to support it?
Actually, the Dr. Amila said that he is one of the co-investigator of the project, and he is doing that part.
Okay.
So I have no idea about the cost of that part. But when we do in heavy metal analysis in water, basically, so Slimtech and some universities also have ICP-MS, and Slimtech, they take in around 5,000 per analysis, I think.
Right.
Irazim also has one. I have to check the cost. Actually, I haven't used it before.
Yeah, please, Avanti, because I think these are helpful, right, Sena? To have this information. So we can, I think with this kind of information, let's have another event probably early next week, so that we will be talking about the sampling locations and things like that.
Hello?
Yeah.
So Dr. Anand, when we get back to the water sample analysis, POPs and pesticides, so normally ITI, they taking 25,000 per sample.
Hello?
Right.
But only few chemical compounds we can identify.
Yeah.
Since when we go into quantification side, so we need standards, no?
That's right.
So, then most of the institutes, universities, so they have their relevant standards only. They have no general standards list. That's the thing in Sri Lanka. So we cannot screen all the chemicals related
No,
to
we
POPs.
cannot. We cannot
target specific ones.
Right. And also pesticides still is my feeling that in Sri Lankan waters, they are highly diluted, and the residue level is like way below ppb. So it's highly unlikely, unless the particle piece of plastic has been around a long time and then accumulated so much. So the chances of we finding these things also is, we are not in a superfund site now.
Yeah.
So it will be very highly unlikely. So
yeah, but I did pesticide analysis during my PhD, the Canal River Basin. So I could find that some concentrations nearby paddy fields, pineapple cultivation areas, and some tea cultivation areas. So then I targeted some pesticides, what they are spraying into their crops. So those daughter compounds I could find out from the water. But they are not much levels, as you said, but there are.
keep that in mind when you decide on the sampling site, so that probably we can target one or two of those physical processes, agriculture or industry, and then probably tie up the sampling scheme like that. So Sena, over to you.
Yeah, I think what's important is both these rivers are running through plantations and then agriculture, and then also through industries. Yeah. So we have to, I think, have it in mind when we do the sampling, thinking of the sampling. So anything else you would like to say from the university side, your side? Dr. Avanti, anything to be added?
Oh, you might have questions also. Please do ask. So we will try to clarify about the project or durations or anything that we can provide, we will provide.
Yeah.
So Dr. Anand, what is the duration of this project?
This one, the first phase will go about 6 months. That's where we need to start characterizing as much as possible. And then the second phase will get oriented based on what we find. And also I think ocean plastics is going to go up. I think the tracking and monitoring will never go away. Now, for example, now there is a group who is interested in knowing ocean plastics coming from each stream in Sri Lanka. Now, whatever the objective, the tracking and monitoring will, I think if we can get a good system established in the country, there will be a lot of opportunities for us. So through this project, let's get that system established.
And what is the ultimate objective of this project? The final objective, I mean.
It's to get a better understanding of the condition of the two rivers, the frequency of plastics appearance, and some kind of indication of the volumes.
Dr. Avanti, I hope you are aware of this countermeasure project in Mekong River and Ganges. The idea is to actually help the countries to minimize the land-based plastics going through the rivers to the ocean. So we have never done any mapping of plastics in rivers. So this is actually, we have selected the two rivers, and then probably you may know that there is another project called Surakimuganga, which is covering all 103 rivers in the country, and they are looking for our outcome as a sort of a demonstration for them to expand this to all the other rivers as well. So we have to give some very good results based on how much of the plastic mapping where and how, not quantified, but the mapping of the plastics going in the rivers to the ocean.
And Avanti, there's one component in the project to summarize the technologies that are suitable for Sri Lanka to trap plastic, and also to commission 1 or 2 trapping points in several locations. So in that, we will be working closely with the Mass Holdings and the MIPA. They have already several sites ongoing. So that, so basically characterization and then technology verification, and then testing some of the pilots on the ground. And then eventually all this will lead to policy and the plastic management at the country level.
Thank you.
So if you don't have any other things, probably sometime next week, we can again have a meeting. What is the most convenient day and time for you, the three of you? And it should be convenient to Anand also.
For me, it's good Mondays and Thursdays, but I don't know, sometimes the faculty announce sudden meetings. If so, I have to.
No, we will
because
check
of
with
the
you.
COVID.
Yeah. What about Dr. Pradeep and Dr. Johan?
Yeah, normally I am free on Thursday and Friday.
Right.
Anytime, okay.
Dr. Johan?
Yeah, Thursday and Friday also okay for me.
Yeah, I think tentatively we'll think of Thursday today, but Anand, we will looking in your calendar also, and when we will decide.
Next Thursday is fine, Sena, because I was supposed to go to Mana, and then that trip got COVID. So, so I'll be here.
Yeah. So we will, I mean, today we will think that we'll have another meeting on Thursday. So that day we'll discuss, go more into details. Right.
Yeah, Mr. Sena,
Yeah.
I have one more question. So what kind of role we are playing in the project, as a consultant or as a scientist?
Yeah, I think this is the question I was thinking, but Ananda has suggested that, can you, I think, elaborate, Ananda, probably?
Well, I think both, right? I mean, this data is, once you collect that, I mean, you are, there's no restriction to use this data for your continued work. And also to do joint publications and things like that. So in that context, I think you are a researcher. Then, I mean, this is additional work for you anyway, and for your students. So in that context, you need to compensate. So for that, I think we can use project money to compensate the work, the expenditure. So in that way, the consultant or resource person modality comes in.
Okay. Okay, thank you, Dr. Anand.
So then I think, thank you very much. We can, I think, conclude the meeting. And we will meet on Thursday again, and we will discuss more into the sampling, I think, details discussion and any other details. Because by that time, we also will have more clear picture and maybe more definite, I think, terms on the project. So,
what time on Thursday, Sena?
can we have the same time?
9:30? Fine.
Yeah.
I'm okay.
You can use the same link.
Can
I think, yeah, Kirti, what I sent you is, I think Kirti is a recurring link, so we can use it, and we will anyway tentatively plan it, and we'll keep you informed. We'll send you a reminder.
Before closing,
Nihal has joined. Nimal, yeah.
I was there. I was listening.
I say.
Yeah, actually, one thing I can, if I can ask from Dr. Pradeep Johan, is there any particular operational manual for this particular sampler, which we can refer prior to this one, prior to do the sampling arrangement or the planning? Could you hear me? Could you hear my question?
Hello, to me, is it?
Yeah. No, what Nimal is asking whether there's any operational manual related to the sampler.
Sampler, yeah.
Yes.
Dr. Pradeep, we have him?
Yeah, we have. Yes.
Yeah.
But it is in Japanese. That's a problem. Anyway, we can search in the website that they have some English translation.
What is the exact, no, what is the exact name? Can you put it to the chat box? Then I can, search it.
Albatross, no? Albatross.
Albatross sampler.
Albatross sampler.
Yeah, albatross.
Right. That's actually a product of Pirika, is it?
Yes.
All right. Then it's easy. Okay, thank you.
Okay. Right. So, shall we then conclude the meeting, and we will see all of you next week, Thursday. Thank you for joining today, and it's a pleasure working with you.
Thank you.
Thanks all.
Okay. Thank you, sir. Okay.
Thank you.
See you. Bye.
Bye.